Alright, so here we go. Let's see how he did. Mr. D parks his car at where point A is, wants to go scout the forest for optimal hunting locations. He starts walking in this direction, no distance given, until he reaches a spot, point B. So we're going south 35 west. So I'm going to have my diagram as follows, right? And I have my compass rose there. And I'm starting south and I'm turning 35 west, like this. Okay, so this is 35 right there. And then, so this is point A here. This should be point B for me. And then he continues north 19 degrees west, right? So technically, if you want to, I would still say do a compass rose, but it's 19 west, north 19 west. So your compass rose kind of follows you where you are. So north 19 west, 19 shouldn't be, this is 45, right? 19 should be about that. And then until we get to point C. Okay, big mistake is to assume that we're gonna be perfectly lined up with where we started. Don't make that assumption. So I always make an effort to not make that mistake, so I kind of cut it a little shorter here. That'll be point C for me. I know this is 3.8 kilometers because, right, the direction has a distance attached to it. And then the distance from the second spot to his car is 4.7 kilometers. So this distance here is 4.7. So you can close that and say this is 4.7 kilometers. So that's your interpretation. That's usually worth a mark. We can bring the 35 in here, just this part right here. This is 35. And I forgot to put the 19 in here. That should have been done earlier. But that combination gives you the one angle you should get. You should only get one angle for the most part, right? And then I suggest you make a copy of it. Okay? Make a copy. This is A, B, and C. The 35 is gone, but we know this is 4.7. This is 3.8. And what would this be? 54? That is gold here, 54. So this is A, B, and C, just like that. And now we have a pair, so definitely sine law. What is it asking? We'll calculate the total distance traveled. So we want everything around. So what can you do at this point is use sine law with this pair, right? And this side will allow you to find this angle. That's all you can do at first. Once you've got that angle, right, you can find a third, which will allow you to find this side, which will allow you to find the total distance traveled. Is it a crazy question? Somewhat. It is a lot going on, right? So it would be probably not this big on an exam or cumulative. I wouldn't do everything in one shot. I'd probably break it down a little bit. But let's go ahead. This is sine of 54 over 4.7. And then it's sine of A over 3.8. You cross multiply and divide. So sine of A is 3.8 times sine of 54 over 4.7. This gives you 0.65, yeah, 4 and something. So to find angle A, you use sine inverse of 0.65 and something. Angle A gives you 40.85 degrees, okay? So that is important. This whole thing would usually give you 2 marks already because you have to find a sine law, solve, and find the angle, okay? Next. Yeah.
When I plug into the computer, are you in degree mode?
You're in radian. So go to mode. Press mode right there. Yeah. And then go switch to degree. Were you always in radian this whole time?
I think so.
Did you do okay on trig? Okay, anyways, we'll talk later. So we now know this. We can find angle C. I will just give you the answer, 85.15, based on this angle. Okay? So that's also important. That's usually worth a mark. And then I do a whole nother sine law. You choose. You could do cosine law at this point, right? Because you've got side angle side. You could use that to figure out side C. But I use the pair that I have, sine of 85.15 over side C. Side C is 5.79. Okay. Kilometers. So total, if you add up this and the two sides that are there, would be 1429 kilometers. This is really what the question was after. A bit overkill, but it still gets you thinking. That's the main idea for this AC, to get you to think, go back to trig. I think it would have been nice to use cosine law here. I should have maybe, just to review that. Okay. All right, next. There's going to be one compass direction and one that is either angle of elevation or depression. So there should be no surprises there. Right. So this is camping here, 20. So the high cliff diving from the highest spot, which is 20 feet above water. Since he jumps up just before leaving the top of the cliff, he reaches a maximum height of this, right, 24 feet after 0.82 seconds. That is the max, or the vertex. Okay, so vertex is given here. You kind of have a sense that this is going to be a story. No equation provided, so you're going to have to do that, right? So you start at 20, jump up, reach the maximum, and eventually we splash into the water. But don't fall for the splash, okay? You starting at 0.20, this is 0.82 seconds, and you reach 24, that's the highest. You will find a third point that is across your starting point, not down here. So that you get back to 20 on your way down, and it will be 2 times this. That's right, 1.64. So this is usually worth a mark, like finding that third point. Then you go stat, calc, quadreg, and you get negative 5.959 x squared plus 9.756 x plus 20, right? If you enter that into your calculator. And that is the quadratic equation that models this. How high is Chip after 1.8 seconds? That would be, this is all of A, right? B, all you need to do is go second trace value, that's correct, and let X be 1.8 seconds. Because you know X, right, that's your time, and Y is going to be 18.29 feet. Okay, so this is what we're after. As long as you have units next to it, and you circle that answer, you're good to go. Okay? C, what's the domain in this situation? We are assuming, obviously we're going to hit the water, right? And at that point it usually stops unless we're told otherwise. Because technically then they would reverse, right? The parabola would point up if we were to include under the water. So we would just go from 0 all the way to this point right here. So it requires some extra work. This point is 2.830, right? It takes 2.83 seconds to get to that. You have to find it using the x-intercept. And so this would be the domain in this situation at the time where you splash into the water. Okay, so there we go. I should do, what if she hits a rock that's 3 feet above ground? No, I'm just kidding, that'd be rude. Anyways, sorry. So there we go, that's that. Let's do this one here quick. How many solutions? I don't know where you wrote this down, but you kind of want your fishing rod and your string, right? This is your string, this is your rod. The angles and the side, this pair here, you want the angle here and the side across, right? 13 meters goes here, and therefore 19 goes over here. Okay. So what's the first thing we check? String compared to the rod. The string is obviously shorter. So you're right, then you need to find the height, which is 19 times sine of 50. What is it? Okay, I checked it earlier. So meters. And then you conclude, you compare your string and your height, because once you get into this route on your chart, there's 3 options after you find the height. And the string is shorter than the height. Like this height that you found, right, the string is shorter than that, so it's never going to touch the ground. So therefore, no solution, right? No solutions. Or 0 solutions, it's up to you. That's how you do it. Do you remember, if I told you the exterior angle of a polygon is 36, would you know how many sides it has? Use the formula. So the 360 over n, correct? You know that exterior is 36. You go 360 over n, put a 1 here, cross multiply and divide. So it'd be 360 divided by 36. N is equal to 10 sides. And there may be, on the short answer, there might be something like this. So you just need to be able to plug it in and solve it. But they won't be long, right? So keep that in mind. Backside. Oh, you gotta love this one, right? Blast from the past. JHIK is a parallelogram. What does that mean? That these two sides, like this is parallel to that side, and this side here is parallel to that side right here. That's what a parallelogram is. How do you want to start? I think I'm going to start with X. This is my first one here. You got to think of it this way. These two lines are parallel, right? 86 is touching the parallel line and X is touching the parallel line, so this is a transversal. So I can bring the 86 into there. Okay, so that's 86 degrees. Alternate interior angles are congruent. That's what I used for that one. Okay. Then I can use corresponding if I wanted to, right? This whole thing, no, not corresponding, CIA, sorry. This and this, remember, are all is consecutive interior angles. And we know that they add up to 180 when things are parallel. So I'm going to go 180 minus X minus 58. That is 180 minus 86 minus 58. Okay. That would be 36 degrees. And I'll just go CIAs here. All right. A, sum of triangle if you'd like. Yeah, there's a triangle here. So I'm going to go 180 minus X minus 58. Okay, so 180 minus 86 minus 58. That's 36 as well, right? 36. Sum of triangle. Yeah, you could have also used alternate interior because this line is parallel to that one, right? And so both A and Y are touching the parallel lines. Okay. And Z, last but not least, right? There's a straight angle here, so you know that all three here must add up to 180. You know what? I would just this 58 is also 58 here. There's like the parallelogram. These are the same, and so are the big angles here. Like this whole thing is parallel. So if you wanted to put the 58 here, right, and then just say that Z is 58 because it's corresponding, that would have been fine with me as well, as long as you have that written in here, because this is accurate. So whatever you chose, right? Corresponding angles are congruent or supplementary angles, right? You decide. So that leads into the inscribe. Whenever you have inscribe, folks, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is equal to 12. Do not double count. X is one of my interior angles of that big polygon. So it's really 12 minus 2 times 180 over 12. And so x is equal to 150 degrees. So that's 150 up there. Let's do y next, because I'm going to use this diagonal and work with this. This is a pentagon, right? Penta. I'm going to figure out y here. I know that the interior angles of a pentagon add up to 540 degrees. Minus, I've got 1, 2, 3 x's or 3 interior angles there. So I just subtracted like that, okay? And then I split everything in half because these two are the same. So I take away these 3 and then divide what I have left in 2. That would be 45, yes. I'm just going to give you the answer, but you got to be careful to do the top first, then divide by 2. Okay. Z is right here. I know that this is 150 and Z is an exterior angle. So you could either go 360 divided by 12 or 180 minus 150. Okay? So that's 30 degrees. Or exterior angle is 360 divided by 12, which is 30 degrees. Whichever one is easier for you. Oof, time is flying. Solve the following triangle. I would start with an SAS. You have to start with SAS. There's no way around it to solve for side F. Okay? So F squared is equal to 105.7 squared plus 78.9 squared minus 105.7, 78.9, cosine of 65. F is equal to square root of whatever you get here, which is 1034.8, yes, 0.65, and that keeps going. So F is equal to 101.73. Not degrees, meters. And then everything else from there, what's that? Sine law if you want. Yeah, you choose, but you have to start with cosine law in this case. Okay, you get to keep this, of course. I will post the video on the test review, okay? The test review for the quadratics. I'll post that.